In this video, we are going to look at more constant acceleration formula. So we've already got these two. V is equal to u plus at, and s is equal to half of u plus v times t, where s is displacement, u is initial velocity, v is final velocity, a is acceleration, and t is time. So we're going to make some more formula, and we're going to do that by eliminating v. So we've got v is equal to u plus at. So we're going to substitute in to our second formula, in for v, u plus at. So that becomes s is equal to half of u plus, and instead of v, I'm going to write u plus at times t. So I'll write half t at the front, and then u plus u is 2u. So I've got half t times 2u plus at, and then just expand the brackets. Half times 2 is 1. T times u, we write as ut. Half t times at is going to be half at squared. So s is equal to ut plus half at squared. So that's another formula we can use now. So now we've got a formula without v in it. So a formula that links s, u, a, and t. And we can do the same if we eliminate another letter. So let's eliminate t from both of these. So I'm going to make t the subject of both of them. So v minus u equals at. So t is equal to v minus u over a. And then for my s formula, I'll double both sides. So I'll get, I'll write it, 2s equals u plus v times t. And then to get t by itself, divide both sides by u plus v. So t is 2s over u plus v. So now I've got t equals in both of them. So I can write them equal to each other. V minus u over a equals 2s over u plus v. Get rid of the fractions by multiplying both sides by u plus v and a. So I've got v minus u times, I'm going to write it the other way around, v plus u is equal to 2s times a, 2as, just writing the letters alphabetically. V minus u times v plus u, if we expand the brackets, it's the difference of two squares. It's v squared minus u squared. So v squared minus u squared equals 2as. So v squared equals u squared plus 2as. And that is another formula we could use. So now we have 4 formulas we can use. If we eliminated u, we would actually get another one. I'll just make a note of this down here. So instead of s equals ut plus half at squared, we would have got s equals vt minus half at squared. So that is actually another one we could use as well. So now we have these 5 formulas we can use, and each formula is missing one of the letters from SUVAT. So there's one without S, one without U, one without V, one without A, and one without T. So we always know which one to use by knowing which letter is not in it. And let's look at a question. So a particle moves in a straight line with a constant acceleration 2 meters per second squared. The particle moves 44 meters in 6 seconds. Find the initial velocity and the final velocity. So let's write down what we know. So the acceleration is 2. The displacement is 44. And the time is 6. So to find the initial velocity, we want a formula without v in it. And the one without v in it is s equals ut plus half at squared. So we just substitute into this and find u. So 44 equals 6 times u plus half of 2 times 6 squared. So 44 is 6u, half of 2 is 1, 6 squared is 36. So take away the 36, that leaves us 8 equals 6u. So u must be 8 over 6, or 4/3 meters per second. We now need to find v, but now we actually know every other letter. So we can actually use any of them. Let's use v equals u plus at. So it's 4/3 plus 2 6s. 4/3 plus 12 is 40/3. So 40 over 3 meters per second. One question for you to try. See if you can give it a go. So a particle moves in a straight line, constant acceleration of 3. So a is 3. The displacement is 50 meters. Time is 5 seconds. Let's find the initial velocity again. So we're going to use the one without v in it. S equals ut plus half at squared. So 50 equals 5 times u plus half of 3 times 5 squared. Half of 3 times 5 squared is 75 over 2. 50 equals 5u plus 75 over 2. So 50, take away the answer. 25 over 2, or 12.5, is equal to 5 times u. So divide by 5, and we get 2.5. Then we need to find v. So we can use v equals u plus at. So it's 2.5 plus 3 times 5. 2.5 plus 7. 2.5 plus 15 is 17.5. A car is moving with a velocity of 18 meters per second. When the driver applies the brakes, the car decelerates to rest with a constant deceleration, 12 meters per second squared. Find the distance traveled as the car decelerates and the time taken. So what do we know? The initial velocity is 18. It decelerates to rest, which means the velocity goes down to 0, and it's got a deceleration, so negative acceleration, of 12. What is the distance traveled? So we want to link displacement, initial velocity, final velocity, and acceleration, the one without t, which is v squared equals u squared plus 2as. So it's 0 equals 18 squared plus 2 times negative 12 times s. 2 negative 12s and negative 24. So plus 24s to both sides. 24s equals 18 squared. So s is going to be 18 squared divided by 24. 18 squared divided by 24 is 13.5. 13.5 meters. What's the time taken for the car to come to rest? So again, now we know all the information. We can use any of the other formulas. I'll do v equals u plus at again. So 0 equals 18. plus negative 12 times t. So 12t is equal to 18. T is 18 over 12, which is 1.5 seconds. One for you to try. See if you can give that one a go. So it's the same question. It's initially got a velocity of 16. It decelerates to rest. The deceleration is 10, so it's negative 10 acceleration. What is the distance? So v squared equals u squared plus 2as. 0 equals 16 squared plus 2 times negative 10 times s. So 2 negative 10s are negative 20, plus 20s to both sides. So 20s is equal to 16 squared. So s is 16 squared over 20. 16 squared over 20 is 12.8 meters. What's the time taken? So any of the formulas that involve time. So we've got 0 equals 16 plus negative 10t. So t must be 1.6 seconds. And one more question. A particle moves in a straight line with constant deceleration of 4. That's negative acceleration. Points A and B lie on the line. It's 36 meters. When t equals 0, it passes through A. Initial velocity is 18. Find the values of t when the particle is at B. So what's going to happen here? We've got A and B on a straight line. It's decelerating, so it's moving in this direction. It's moving along in this direction, but because it's decelerating, eventually our velocity is going to turn negative and it's going to come back again. So there's going to be two values of time when it's at B. So it's going to be moving forwards, and it's going to turn around and move back again. And what's the formula? So we've got S, U, A, and T. We've got S equals UT plus half AT squared. And we can see it's going to make a quadratic because we've got a T and a T squared in it, which is how we're going to get two values. 36 equals 18t plus half of negative 4 times t squared. So 36 equals 18t minus 2t squared. Let's move everything to the left and half it, one at a time. So 2t squared minus 18t plus 36 equals 0. So t squared minus 9t plus 18 equals 0. And we can factorize this one. So it's negative 3 and negative 6. So t could be 3 seconds, or t could be 6 seconds. So it passes through B after 3 seconds and after 6 seconds. And one for you to try. See if you can give it a go. So what information do we have? It's got a deceleration again of 2. Displacement is 36. Initial velocity is 15. And we want the times where it's moved 36 meters. So the 2 times it's at B. So S is equal to UT plus half AT squared. 36 is equal to 15T plus half of negative 2T squared. So 36 equals 15T minus T squared. Let's make it equal to 0. T squared minus 15T plus 36 equals 0. We can factorize this one again, but you could just use your calculator to solve it as well. It is negative 12 and negative 3 this time. So T is 12 seconds and T is 3 seconds.